Hello, hi everyone. So today we are going to talk about one important topic, which is large data volumes. Uh, while it's easy to understand or it's easy to work with limited amount of data, but when the data size increases in Salesforce, there are a lot of technical challenges which come up, and we need to understand. This is primarily for architects. If you are an administrator or developer, of course, I would want you to understand these concepts, but primarily the architects need to understand how to deal with large set of data. How do they work with that, and what are the different strategies that they can take up. So I'm going to talk about those things. It's one of the common issues that a lot of companies come across or face, right? So first of all, let's quickly get started and talk about what works fine, and when do things start actually causing issue. So why is large data volume even an issue? Okay, so most of the times we consider, when we are talking about data, the size of the data, the volume of the data, most of the times we are trying and talking about the sorry, excuse me. So most of the times we are talking about what we are thinking about, the storage capacity of the data, but it goes beyond that. There are a lot of things which get impacted. Now, when do things get impacted? So what would work fine at 10,000 records will not work, or will start failing at 50 million records. So the volume of the data does play a big role here. Okay, so something which is absolutely working fine for 10,000 records will not work properly when your data volume grows significantly. If it becomes say 5 million, 10 million, 50 million, it would start certainly breaking. So now, what is important here? So it's not just again about the storage only. There are a lot of other factors which would come into picture. So your if you have more records, your overall system will become slow, and a lot of processes will start. Okay, your queries, reports, automations, everything starts getting impacted. All right, and it depends on how well you are managing or optimizing your large data volume strategies to deal with this. Otherwise your system will start, as I said, failing. Some automations will fail, processes will take a lot longer to execute, etc. So now we'll quickly go to the next one. Why doesn't it move? Give me one moment. Okay, so let's quickly look at the agenda, and what are we going to talk? We will be discussing about give me one moment, let me get this sorted. Okay, let's quickly talk about the agenda. So first of all, we'll talk about what counts as LDV, what counts as large data volume, when should you start getting concerned. Second, we will talk about why performance degrades, what are the factors which get impacted, where the performance starts getting degraded. So that is the second thing that we're going to talk. Third is indexing, the best practices. We'll talk about indexing and the best practices of indexing. We will talk about understanding data skew. We'll talk about query optimization. So data skew is a completely different topic. I'll talk about what is data skew, when does it happen, and all. Then we'll talk about query optimization, and then we will also talk about archiving strategy. All right. So these are the things that we are going to discuss. So first thing first, what counts as large data volume? So first thing, there is no, I mean, there's no such fixed number that okay, fine, these many records will count as large data volume. So primarily, when we say large data volume, it is more of a subjective thing. but still there are ranges where you should start considering, the factors uh, related to large data volume challenges, etc. So if you have, say, and I'm talking about number of records that you have per object. Okay, so if you have, say, 10,000 records in an object, absolutely not an issue. Tens of thousand records, say 100,000, 150,000 records in an object, that is also not an issue. If you have till a million record also, that is where it starts getting a little uh, towards the large data volume, but still manageable. That's okay, still manageable. But if your data is increasing from, say, 1 million to 10 million, if you have more than 1 million records in one object, then of course you are required to start thinking seriously about large data volume. And if it is more than 10 million, of course you will have to have solid optimization strategy for large data volume. Otherwise you will be getting into trouble with the performance degrade, etc. So that's basically the definition of large data volume. Again, as I said, this is pretty much subjective depending on what sort of fields we have and all that stuff. So a lot of things play a role. So something which for one object things may start breaking at, say, 5 million records, and for another object things may start breaking at 10 million records. So, or things may start slowing down, if not break. Okay, now, why large data volume matters? Why is it such an important thing, and why we should have an optimization strategy for this? So there are certain things which would get impacted. So what would get impacted? First thing, your query performance will get impacted because of the large data volume. So your queries will start getting impacted. Queries will not, some long queries will not get executed. They will fail, or they will take a lot of time to get executed. Your list views will, okay. So first is query. Let's talk about the second point as reporting. I'll come to the list view later. Reporting, your reports will take longer to generate because, of course, there is a lot of data inside it, and your reports will start running slowly, or incomplete results they will show. Third thing that gets impacted is the list views. Your list views load slowly, and you would most probably hit the row limits very quickly. Fourth will be the data loads. So if you have large data volumes, your data loads, data management sort of activities will become slower. Your automations are also going to get impacted. All your flows, processes, triggers, etc. Will take longer to get executed, and that's going to be impacting your overall performance of the system. Now, the core problem. The problem is about selectivity. So what happens with the large data volume. So what happens? Let's quickly understand one thing. So Salesforce has got a data model that we work with, right? But below that, under the hood, there is another data model which Salesforce maintains on its at its side, right? So all our custom objects, custom fields, these are basically a separate table. So when we are writing a query, we are not writing a query which gets executed. We are basically writing SQL queries, and these SQL queries are not directly like SQL queries which are getting executed on some table, right? So under the hood, Salesforce has maintained all these things in another table. So all your custom objects, custom fields are in another table that it has created, which of course is not visible to us. So the query that we write to retrieve the data, that query gets transformed. So actually under the hood, what is happening? The query that we are writing, that gets transformed into another query, and that query again goes and gets executed in the actual database, and then it returns the result, right? So if you see, the process is not very simple, straightforward. So this, on top of because Salesforce has made things simpler for us, but at the same time under the hood there is a little bit of extra execution which is happening, which we need to understand as well, that also adds to the load of the overall execution of things, right? Now, in this case, so there's very little that we can do about what is happening under the hood. That's more for our understanding, but we cannot change that. That's how Salesforce architecture is. The product is designed. That's how it is architected. So that's not something which is in our control, and we cannot do much about it. The reason why I spoke about it, because I want you to understand that there is additional load or impact on any query that we are executing. Now, the core problem is, now what we can do is we can at least try and make our queries optimized the way we are retrieving data, because if it's large set of data and if we have written queries which are not properly optimized, the query will of course take a lot longer, right? So there the core problem is selectivity. So if your queries are selective, those queries will get executed faster. At the same time, if your queries are non-selective, then those will take time and will not get executed that faster, and you will have the risk of queries getting timed out or failing, etc. Right? So high selectivity queries, have faster performance, and low selectivity queries have slower performance. Okay, I'll talk a little more on this, but before that, let's understand indexes. Okay, so indexes are basically the you know the fields which can be quickly indexed, and which can be used for querying the data. All right, so there are standard indexes. Now when I was talking about I was talking about selectivity of the query, right? So there is one thing which we realize here is, if you use indexes in your queries, then Salesforce is able to quickly go and search the data. So I'll give you an example. Okay, I'll give you an example. So you're working in a company, there are 10,000 people in the company. All right, now what happens is, you have to search for a person in that company. All right, so if you have to search for a person in that company, it would be easy, if I just give you the first name, then what happens? It becomes difficult for you to basically go and search for the name, because there can be many people with that first name. So you end up searching across different people. Maybe you have got a first name, and have got 50 people with that same first name, or maybe 100 people with the same first name, and then you are trying to figure out. You spend a lot of times you spend a lot of time figuring out who the person is, right? At the same time, if you have the employee ID of that person, will it not be easy for you to basically go and search the person? Or if you have the email ID of that person, will it not be easy for you to go and perform the search? Or if you have the phone number of the person. All right, so there are certain data. So for example, if I give you first name, or if I give you a last name, it's going to take longer for you. And if I give you, say, employee ID or the phone number or the email ID, then it becomes a lot more easier for you to go and quickly search for the person. Same thing is applicable here. So think of your email ID, employee ID, those as the indexes, which will help you do the search quickly, versus the first name, etc. So that is the thing. So whenever we are also writing a query, we should basically think from that perspective. So the fields which are indexed within the Salesforce, those can be your queries work faster with them. Those are able to perform fast with them. But if you are using non-indexed fields, then it becomes a little more time consuming for the queries to get executed. So it's not that, again, you always have to use that. Sometimes you will need to use non-indexed fields, but with large data volumes, it becomes critical that the indexed fields are used in the queries, etc. Now, there are two types of index fields. There are standard index fields. So by default, the standard in Salesforce has got some fields, and there are standard index fields. So which are the standard indexed fields? ID, of course, the record identifier. Name, the name field, the default name field that every object will have. Created date is indexed field. Foreign keys, any foreign keys or the lookups, master detail relationship fields. All relationship fields are indexed fields. And any unique field. Okay, so any field which is marked as unique, those are index fields. Again, because if the fields are unique, it is easy for Salesforce to search. The same example, again, think of it. Employee ID, email ID, those are unique, right? So multiple people will not have the same email ID. Same way, any unique field is by default indexed. So these are the standard index fields. In addition to these, You can also add custom index fields. Okay, so now custom indexes are basically the fields, additional fields that you want to index. All right, now that's something which you cannot do yourself in Salesforce. You'll have to reach out to Salesforce support, and you'll have to raise a request or a ticket with them, support ticket with them, and the process is pretty simple. They will review, and then it will be approved, and then those custom indexes will be added to your uh, Salesforce org. For example, here I've taken a scenario. I've said I want region to be an index field, so I can raise a request with Salesforce, and they will review, and then they will approve, and then that region will become an index field there. Okay, so again, things you may be thinking that, oh, I keep on running query on so many custom fields, doesn't matter at any point of time. It would not impact you if you have, say, again, as I said, 50,000, 200,000, 500,000 records. It does not impact that much. But if we are talking about large data volume, so if we have, say, 50 million records in one object, then we will have to consider these things. So if we are reporting using any particular field, or if you're querying some data using one particular field, it would be a good option for us to get those fields also added as index fields, custom index fields. Now, the next problem that we are going to talk about is, so indexing is one. The next problem that we're going to talk about is the skew problem. Okay, data skew is basically when you have a lot of records associated to one owner, or a lot of child records associated to one parent. Okay, so first of all, we'll talk about the ownership skew. Ownership skew happens when you have, so if you look into this image, you would see that there is one owner who owns a lot of data, versus there are multiple other owners who are owning little amount of data. So there's many owners with very few records is not the issue. The issue is one owner owning a lot of data, right? So now this basically creates a lot of issue, because if you have majority of your data assigned to, not majority, if you have hundreds of thousands records assigned to just one single owner, it will continue to cause problems for every sharing, recalculations, etc., because it's going to be for the same, a lot of records are owned by the same user, etc. Record locking issues will keep on coming up. Your performance and automations will slow down. So those are going to be the issues. So what is the solution to this? The solution to that is that you should have data distributed properly amongst the owners, and it should not be the case that one owner owns a lot of data. Now, when does this scenario occur? Now you may be thinking, why would this scenario occur? A lot of companies do have some dummy user or a dummy owner, and who whichever data is not assigned to anything is basically assigned to this particular owner. So that sort of concept. So usually it will not be that, okay, fine, there is one sales rep who is dealing with, say, 70-80% of the data of the company. That would not be the case. But this, in most of the cases, this comes up where company is not able to decide on something, and all this data where there is no decision is dumped into one single owner. So that is where the problem comes in. So there has to be a mechanism to distribute the data. If you keep the data like this, then certainly you are going to uh, come across this ownership skew. Again, if you just have 50,000, 100,000 records, it may not be that much of an issue. But yeah, in at large volumes, it will certainly start becoming a big issue. Then there is lookup skew. So the first skew issue was the ownership skew. Now the other one that we have is the lookup skew. Now what is the lookup skew? Lookup skew is basically when there are a lot of child records which are connected to the same parent record. Okay, so again, the reason is same. If you're not able to associate a child with any particular parent, you just start dumping everything under one particular dummy record, dummy parent record, dummy account, or something like that. That also becomes an issue. So let's say you are basically getting contacts, and if you do not have have the details of the account for that contact, you start moving everything under one dummy account, etc. That's where this problem comes in. Okay, one parent record, and multiple large volume of child records associated to the same parent. Now what is the problem with this? Again, here you will find issues with record locking. Now, why does this problem come up? Because whenever we are doing an update, what happens is when record is getting updated, so during the process of it, there are if you have gone through the order of execution, you would see that the child record is getting updated. It will basically have some, it may have some updates in the parent as well, etc., right? So for the timing when the child record is getting updated, the parent is kept locked so that the parent does not keep on changing when the child is being created, updated under that particular parent. So parent record is kept locked during that particular period of time. But if you have too many records, under the same parent, then there is a possibility that in a batch of 200, there are 50 records under the same parent. Then a lot of records will fail because they would find that the parent is locked because by some other record, right? So if there are like 50 records, the first two records could use the parent, could lock the parent, but the other records are not able to lock the parent because multiple transactions happening parallelly on that particular record. Okay, so record locking becomes a problem. Your updates will definitely take longer. Even if the record locking is not an issue, it will, you may have to process things in smaller batches, chunks. You will have to go one by one by one, which will definitely make things slower, and your performance will definitely degrade. So this is the second type of skew. And then the account data skew, which is the parent child data skew as well. So this is again one common problem, very very similar to what we discussed in the previous one. Okay, so here it's more about account getting associated to a lot of child records and child of child records, etc., because account is one of the parent records, and from there is a bit of hierarchy which comes down. Okay, so if there are a lot of records associated to account, which will then continue to have more records. Let's say if there are a lot of opportunities under the account, then there are a lot of opportunity line items under those uh, under those opportunities which are associated with the account. So this entire thing again becomes very um, I would say unstructured or unorganized and start slowing down your system, right? Again, the same issues, record blocking, updates will take longer, etc., because you will have when a child record is getting updated, that locks its parent. If there is a roll-up summary, that roll-up summary will get updated, that will lock its parent and all. So that will make things very very complex. All right, so solution to all these problems is always try to minimize the number of records being associated to the which parent, especially for accounts, very important. And no individual user should have a lot of records assigned to it. Now, query optimization basics, next thing that we are going to talk about is query optimization. So skews we have understood, so the solution to that we have discussed. Now for queries we were discussing, how do we optimize our queries. Indexing is one part. Another thing is, we should try and write queries in a way where we are trying to help the so-called uh, engine to run the queries faster, right? So what we should not do, inefficient query versus optimized query. So what we should not do, or what we should try to avoid. So we should try to avoid something like not equals to, not. Okay, so when you're saying not equals to, the query has to basically go search everything and then find where that thing does not apply, right? So not equals to or the not clause, these are really not very optimized way of writing queries. So can work fine with smaller chunk of data, but if it's a regular thing, if it's something which you are executing on a regular basis, try to use specific things, specific criteria. You try to use equals to rather than not equals to. Again, if I take the same example, if I tell you find someone whose name is not equals to this, then it becomes very difficult, right? Rather, if I tell you the exact name, then it becomes easy. So that's how it can be. So you can use these kind of things. You make your queries selective, use uh, use indexed fields. So these are things. So what you should not do as part of inefficient query, you can see, you should not use negative filters, you should not write non-selective filters like, etc. So like keyword can be used, of course Salesforce provides this option, but again this this is not something which is uh, pretty helpful, for SOQL engine to execute. All right, takes longer, right? Optimized query would definitely use selective filters. You will be specifying, what you want to search, etc. You should be leveraging index fields, and this ideally returns smaller chunks of data. All right. Uh, Now, let's talk about SOQL and governor limits at scale. So, how does the governor limit come into picture? Because we, of course, have governor limits, and we'll have to deal with that, or we need to deal with that anyhow, large or small data. But at large scale of data with large data volume, it becomes even more important, right? Because we are already kind of struggling with the large data volume, and now we have governor limits, on top of that. So again, you will have to take care of certain things. So certain governor limits which we should be aware of. So anyhow, there is a governor limit like query row limit 50,000 rows per query. There is a heap size limit 12 MB, and there is a query timeout limit of 120 second per transaction. So those limits are already there, and with large data volume, we'll have to ensure that we are able to uh, understand these and work with these things. And if you're not working anyhow, governor limit is going to basically stop or pause our execution. So that's important thing, and we'll have to keep that in mind, right? So now for batch, first of all, let's talk about if there are process executions. This is something which I'm pretty sure a lot of us are already aware, but let's quickly talk about this one more time. So if you are really dealing with huge volume of data, you can use batch apex for large data volumes. So the core principle is, if you have to process 1 million record, etc., then what you can what the batch apex does, it simply splits the full data size into small chunks, batch 1, batch 2, batch 3, as you can see in the image, and then it processes those in the batches. So that's a standard functionality provided by Salesforce. Out of the box, we have that mechanism available. So wherever we feel that there is there is a need for us to process big chunk of data, try to use batch apex always. So that's something which we should be doing. And then we should be doing asynchronous execution is going to be another key for you. So it's whenever we are dealing with big amount of data or large volume of data, it's always advisable to go asynchronous rather than synchronous, because you do not want a lot of business processes to get executed real time. Because we are, if we have large amount of data, and if I have got a, let's say, trigger which has to basically search for some duplicate value, etc. So uh, we'll have to check the possibility, everything. It's not possible to keep everything as asynchronous, but we should check the possibility of what can be executed asynchronously, so that we are not executing long operations, etc., very frequently. So the different tools that we can help you uh, balance out certain things with large data volume workload. So first is batch apex. We already spoke about it. Try using queuable apex wherever possible. So it's just to ensure that you are able to execute some of the apex asynchronously. Bulk API can be used for large data. If you are dealing with large data loads, etc., then it makes sense to use bulk API. Platform events can be used for real-time integrations, right? Which are executed in a decoupled manner. So those are the tools. Now, another important thing with large data volume is more of having an archival strategy or a data cleanup strategy. So large data volume is a result of data being piled up, getting accumulated over the years, right? So if last 15 years I have never archived my data, over the years, of course, the data volumes will increase. Okay. And so any business, so for certain businesses, let's say there's a business which is generating only 10,000 records in a month, or sorry, in a year. In 15 years, they will only accumulate 150,000 records. So though it's a good practice to archive some of the old data, but it would immediately not start impacting their business processes, etc., right? But if there's a business which is generating, let's say, 5 million records every year, then that business seriously needs to plan and think about their large data, archival strategy, right? So you'll have to understand what do I archive versus what do I retain in the system, and that is going to be a very, very important thing, right? So you have your active database, try to keep whatever is required by your sales team, etc., on a regular basis in the active database, and then have an archival uh, setup. All right. And Salesforce has provided, there's something called big objects. So big objects can be used within Salesforce to archive the data, or you can think of external storage or external database, right? So that is something which can be thought of. If you want to do it within Salesforce, big objects is a good option. So all your old unused records should be archived. So you can have a plan. Think of it, what data, or of which year's data. For example, if I'm working in my system, I need my data till say last 5 years data I need, and I do not need anything before that immediately. So that data can be archived, and archive data is not like deletion completely. So it's just what you retain in your active database versus what you have archived. Okay. So what does it do? It definitely improves your performance. It reduces the storage load as well, and it helps you meet the compliance requirements. And because there are some compliance requirements as well, right? GDPR, etc., where you cannot retain the data forever. So it also helps you meet some compliance requirements, and also it helps you scale your system. All right. Because just because your data volume is increasing should not start impacting your entire performance of the system, right? So having an archival strategy, right sort of archival strategy, is very, very important. Now, reporting at scale. So when you have large data volume, then what do you do with the reporting part? Reporting, again, you will have to understand what do you want to retain, what do you want to report on. If you have already done things like archival, etc., then that plays a role. If you have already have included your filters right using index fields, etc., those things will, because ultimately report is also doing that query sort of thing, right? So whatever SQL query was doing, reports are also doing pretty much the same, right? So if you have used filters on the index fields, etc., then of course you have optimized a lot of things. Additional options for us, sometimes it is important that we use pretty old data also in our report. In that case, instead of using the actual data, you can have some summaries stored in some sort of custom object, etc. Let's say if I have to have some inputs from my 15-year-old data as well in my report. So it's not important for me to have, say, all say there were 10 million records, which I could have archived otherwise, but only for reporting purposes I needed. So you really do not need to um, retain all those 10 million records. If there are key summaries, those can be stored in separate custom objects or analytics snapshots. That is an option available. Salesforce also gives you, an option of something called skinny tables. Skinny tables will be a separate table with limited number of fields. So I really do not need all the fields, right, for reporting. So if I just need 2-3 fields, skinny tables can be explored. And other important thing is basically, if that also is not helping, then of course, if your data is archived, try to see if there's an option or possibility of doing some sort of analytics, the detailed analytics outside Salesforce as well. So that is the thing. So these are certain things which you should consider for reporting at scale with large data volumes. Let's quickly look at one real example. So we are talking about a company with 20 million records in the case object. All right. Now, so 20 million records in the case object, and if you have used unindexed custom filters, so what will happen? Your queries will time out, because there are 20 million record is a significant number, right? Your queries will time out, and you would not get, your system is not behaving the way it should behave, right? But at the same time, if you optimize your queries, you start using the indexes, etc., you include custom indexes, the same report with those 20 million records, the same queries with that object will start working fine. So I'll kind of conclude with this particular thing, this particular slide. So a few quick things for us to take away from today's discussion. So use selective queries. So that's what I discussed. So do not try to query, everything. Just try to query what you need and be very specific. That helps. Let us try and understand how do we help our SOQL engine to get, execute the queries better. Avoid data skew. Any sort of data skew, including your ownership skew, or the lookup skew, etc. Avoid those things. Leverage asynchronous processing wherever possible. Archive proactively. So archival strategy is one thing which every business should have, irrespective of whether you have large data volume or not. Because if you're not doing that, unnecessarily your reports are getting impacted, influenced by something where it should not get influenced. Okay, all right. And you should basically then finally monitor and optimize. So that's the core key concept. I'll try and talk a little more on what are the different tools which are available. Of course, we discussed about some of those things here, but I'll try and make one more um, such video where I'll try and cover few things like big objects, skinny tables, etc., or writing the query planner tool, writing selective queries, etc., in a little more detailed way. So that's something which I'll try to do, so that you also get a little bit of more understanding of those tools. All right, so that's it for today. Thank you.